Years ago, if we wanted to connect a couple of corporate sites, we probably had to get some sort of a WAN connection like a leased line or maybe go into a frame relay or an ATM cloud. But these days, we have such high-speed connectivity to the internet through something like a cable modem, or in my home, I've got gig fiber. We've got such easy connectivity in many places in the world to high-speed internet that we can connect one office location to another office location over the internet. But the challenge is we want to do that securely because the internet is an untrusted network. So we need to come up with some sort of a virtual private network, a VPN, that can protect our data as it's flowing between a couple of sites. So let's think about how we can accomplish that. We know that we can use these common broadband technologies, and the clients, if we're using a site-to-site VPN like this, they don't have to have special software installed. They don't have to have client software. It's going to be transparent to them because the routers or possibly a VPN concentrator is going to be used to do the heavy lifting. So again, the goal is to transport all kinds of traffic between our different corporate sites. And by all kinds of traffic, I mean not just unicast IP, but broadcast, multicast, whatever traffic we want to be able to send it over this protected tunnel. And to do that, let's consider a couple of VPN protocols. The first one is called GRE, Generic Routing Encapsulation. Now, the downside, I'll tell you up front about GRE, is that it does not provide security. The good thing about GRE is that it is super flexible. It can encapsulate just about any type of data. Broadcast, unicast, even non-IP traffic we can send over a GRE tunnel. But it's a bit of a drawback that it doesn't do security. There's another VPN protocol that's very popular that does do security, and it's IPsec, short for IP security. But with an IPsec tunnel, we're going to have a drawback there as well. So let's take a look at the characteristics of an IPsec tunnel. First of all, it is super secure. It's going to give us different encryption algorithms that will scramble our data up and therefore give us confidentiality. It's going to be able to run a hashing algorithm like the secure hash algorithm against a data string and create a fingerprint of it. And if the fingerprint on one router matches the fingerprint on the other router, that's an indication that that packet has not been modified in transit, so we think it's good. That checks its integrity. We can do authentication using something like a pre-shared key or a digital certificate, so we know that the other end of the tunnel is who we think they are. And if somebody were to intercept packets and then try to play them back, because those packets worked earlier, they might work later. Well, we're going to prevent anti-replay attacks by putting basically serial numbers on those packets. So it has lots of security features. Here's the downside though. Unlike GRE, which could encapsulate just about anything, IPsec can only encapsulate unicast IP packets. We'll talk about how to overcome that in a moment. But more information about IPsec that I want you to know. There are two basic modes of IPsec. There's transport mode and tunnel mode. In transport mode, we're going to be using the original packet's header, and we're going to encapsulate the payload of the packet. In tunnel mode, though, we encapsulate everything. We encapsulate the payload and the original header. And the way an IPsec tunnel is set up really uses two different steps. Step one is to establish what's called an IPsec tunnel, or an IPsec Phase 1 tunnel. And as a metaphor, if you've ever watched the TV show, the really old TV show, or now it's a Steve Carell movie, Get Smart, if you're familiar with that show, you might remember the cone of silence that Max always wants lowered when he's talking to the chief about something secret. It never did seem to work right in the TV show or movie, but the idea was you lower the cone of silence and that gives you this private communication area. Well, that's essentially what an IPsec tunnel is. It's like we're lowering the cone of silence so that these two routers can talk securely. What are they talking about? Well, they're talking about the parameters that they're going to use to set up the actual IPsec tunnel, which is also known as the IPsec Phase 2 tunnel. So we negotiate the parameters of the actual IPsec tunnel within the protection of an IPsec Phase 1 tunnel. This is very secure. But how do we overcome this issue? That we can only secure unicast IP traffic. While GRE could encapsulate just about anything, but it would not give us security. What if we use both? Here's what I mean. What if we took whatever the traffic was, unicast, multicast, broadcast, it doesn't matter. We took any of our traffic and we encapsulated it inside of a GRE tunnel. Now we've got a bunch of GRE packets. Some of those packets might contain IP unicast, broadcast, multicast, doesn't matter, but the GRE packet itself is a unicast IP packet. Do you see where I'm going with this? once we put traffic inside of a GRE tunnel, it's now unicast IP packets, which can then be sent inside of an IPsec tunnel. We're going to take our traffic, put it inside of the GRE tunnel, then we're going to put those GRE unicast IP packets inside of an IPsec tunnel. That's how we can use these two different VPN protocols together to meet our goals of giving us flexible, secure communication across an untrusted network, across the internet. And in our next video, we're going to take a look at how to configure a GRE over IPsec tunnel.